Yeah, so I built this PC here and just ripped it apart, so it shows exactly how much I do here. But yeah, there's several different approaches you can do. The three main ones are usually either price to performance, which is what most people do. There's also value, like get the most value out of your money as possible. And then there is overkill, which sort of goes without saying. If you want to do price to performance, the safest thing to do is usually to go on like PC Part Picker or a site like that, something, you know, there's a few different PC building sites you can go on where it let you sort of choose out, like pick a motherboard, CPU, and it does all the compatibility stuff for you. If you're more into it, you can look up what each compatibility thing is, what the socket type is on the CPU, that sort of thing. And you can sort of do it yourself, but I recommend using a PC Part Picker or something like that. And if you want to do a price to performance, you just want to make sure that you have a decently well spec'd out computer while also spending a decent amount of money. So the best thing to do there is probably go on Amazon and be like, that's the #1 bought processor. Well, right now it's one of the brand new ones, so I mean, I can't really say much about that example, but usually, give it another 6 months, and I'm sure that'll resurface. Like the one that we have right here is actually, I think, Amazon's bestseller, just because it's a dual core, which is hyper-threaded with 4 cores. And now what that means, for those of you who aren't familiar, do you guys know what like cores in the CPU are? Well, each one can sort of like perform a task in a sense. And then hyper-threading is Intel's technology where they take the 4 actual cores, or discrete cores, and, or in this case 2 discrete cores, and they divide them up in half. So each one does twice the amount of work. So it's this new thing that Intel's been doing for a few years, and it's really actually really helpful because you can buy a cheaper processor but have it act like a much more expensive processor. So that's what we have going on here. And then the other thing that you're going to want to look into when you're buying a computer is what sort of case do you want. The case is probably the most unnecessary thing, if that makes sense. I mean, you kind of want all of them, but I've seen people, a friend of mine on Facebook actually just built a PC and just screwed it right into a 2x4 edge. I mean, the airflow isn't great, the dust isn't great, but I mean, it works, so kudos to him. Other than that, you do pretty much anything you want. Like, for example, this one is a $30 case. I think this is a $30 case. And I already cut myself on it once today, and that's sure to happen again when I'm installing everything. And the reason why you would want to spend more on a case is there's aesthetic things, like this one, it's a lot of like, you know, just steel that's just sitting there, which doesn't look the greatest. And then there are other things like materials, some are made of aluminum, some are made of glass. And there's also the main reason why you want to buy more expensive cases, because it'll make building it easier as time goes on. So if you ever need to open it up and rewire something, put in another hard drive, if you want to put in more RAM, all that's going to be a lot easier if you have a nicer case. So if you're willing to deal with the hassle, it's fine to get a cheaper case. Just keep in mind that's something you can sort of probably run into. Hence me cutting myself right now. Andrew, yes.
Would a case be important when you're considering cooling, if you want to do a liquid system?
Thank you, Andrew. So with each case, you'll usually see on a spec sheet, like if you're looking up on Newegg or something like that, it'll say two 40 millimeter or like 120 millimeter. What that means is that's the size of the fan. So I don't know if you guys can see this one right here, but this black one right here. I think that's an 80 millimeter fan, and they're known for being kind of loud and moving air, because the whole thing with airflow is that air is kind of a byproduct of noise, or noise is a byproduct of air. It sort of goes both ways, but PC builders are always trying to make their PCs quieter and have better airflow. So there's many different ways you can do this. Like right here, what we're using is a stock Intel CPU cooler, and right here you can see that it's got just one fan on it. It's about an 80 millimeter fan, and you can see there's a silver heatsink on it on the inside, and that heatsink is what's actually taking the thermal output of the CPU is one of the hottest things in your computer, and just dissipating that onto the fins of the heatsink, and then the fan just brings that hot air away. So that sort of illustrates the whole idea that if you want to get cooler components, you're going to need to have some noise associated with it. The motor turns, the fan blades spin, that same deal. Same thing goes with graphics cards, weighing graphics cards. Graphics cards are probably the most important thing you can choose when you're buying a new computer today, especially if you're looking at gaming. This whole talk, by the way, is going to be aimed at some more gaming standpoints, since we're the Husky gamer nation. But so this one right here is an R7 260X. It's an AMD card. It's the last gen of an AMD card, and this features sort of an aftermarket cooler design. Now the difference between an aftermarket cooler and a regular cooler both can perform pretty much the same. In fact, they're usually the same PCB on the back. PCB, or I'm not quite sure what it stands for.
Printed circuit board. Printed circuit board.
Yeah, I suppose so, yeah. And then, yeah, so they all pretty much have the same one on the back, but the reference coolers, you see the word reference cooler being thrown around, what that is, that's just what the manufacturer will put on their card and say, this performs, this has like, it's a reference, it's how cool it should be, it's how cool we make them. And then other companies, like in this case XFX, takes that same card and puts their own cooler on it, which might be able to cool it off better, and if the chips are running cooler, then they can perform better, they can run higher. To go back to the CPU example, with CPUs, if the CPU starts to overheat because, like Andrew was talking about, if the airflow isn't adequate enough and the CPU is heating up, and it's getting to the point where it's going to break itself, like it's going to burn out or something like that, it'll actually throttle itself back. It's called thermal throttling. Great name, right? And what they do is it just brings the performance down because it's rated in gigahertz. Like how fast is it going? Well, mine's at home is going at 3.9 gigahertz, I think. And it'll just throttle that back. So instead of running usually 3.9, if it were to overheat, it would bring it down to maybe like 3 or something. And it won't actually let itself get too hot. And then there's also overclocking to consider, which is pushing the CPU past what the manufacturer says that it will do. And that's totally fine to do. Intel actually offers a warranty you can buy for overclocking, but the main thing is that they don't guarantee a lifespan on it. So they're like, yeah, whatever happens, it's up to you. But if you want to buy the warranty, then we'll replace it for the next 2 years or something like that. Get back to the case. Different fans. This is the 80mm fan. Sorry, I'm getting distracted by the long bit. 80mm fan, and then you've got a 120mm fan in the front. And 120mm is probably the average, I would say, in most cases today. Just because they move a lot of air, they're pretty quiet, they're not too huge, you can fit them in any case. Like, for example, again, my $30 case is a 120mm fan mount, which is pretty good. And as far as component selection, yeah, RAM's pretty universal. You can get whatever RAM you want usually, as long as it fits within what you're planning on using it for. So if you're planning on doing things that aren't necessarily gaming, if you're planning on doing like 3D rendering, you might need more RAM. If you want to build a server, you might need more RAM. But for gaming, I'd say the sweet spot's probably about 8 gigs for what most people are going to be doing today. 8 gigs will get you up and running. And as far as graphics cards go, I would definitely say somewhere in the range of, right now, NVIDIA just released their new line of cards, so I'd probably go, if you're taking notes, maybe a 970 is a decent starting point. But yeah, as far as component selection, does anyone have any questions on anything?
970 what?
970, oh, it's just NVIDIA's 970, GTX 970. Like, it's just their most recent line of cards is the 900s, but they skipped from 700s to 900s, and no one's wondering why. But there's no real answer on it. Andrew, did you have a question?
Yeah, what about RAM speed?
RAM speed. The thing with RAM speed is that the faster your RAM goes, this is actually an 8 gig stick of 1600 megahertz RAM, and the faster your RAM goes, the better it's going to be able to perform, but also the faster your RAM gets, there's going to be more, I want to say latency, but I don't know if that's right. There's different trade-offs going along with how fast the speed. I forget what it's called. I don't think it's latency, but the faster your RAM goes, the more time it takes for it to actually interface or something. There's some odd thing about that. Again, it's not that important to gaming, so again, focus more on the gaming side. Speed really doesn't play a factor. Like, I have 1600 megahertz RAM in here, I have 1600 megahertz RAM in my computer. The only time you would want to get a faster gig stick of RAM would be if you weren't running a graphics card, because both AMD and Intel, the two main CPU manufacturers, both feature onboard graphics now. So it used to be that you would need a graphics card and a CPU in order for the computer to function. Now it's this case where you just need a CPU. And on the Intel side, the integrated graphics are very good. On AMD's side, they have discrete cores, like the cores I was talking about earlier. They actually have some of them which are specifically dedicated to doing graphics performance. If you're running one of those, the faster memory does help because, it's not accessing it over over the bus or anything. It's just like the CPU is using it directly. You're not loading it, or anything like that. It's just all very low level, but very fast things that it needs to do. So if you're not running a graphics card, for some reason, you need to save up for one, you're getting paid next month, you don't buy it yet. For whatever reason, if you are running an APU, you are going to need faster memory, but other than that, there isn't really a benefit to getting more faster RAM. There's a slight benefit, but for the purposes of this topic, is a more beginner-based thing. That's pretty much it. Anyone else have any other questions about component selection?
Is there like a range of numbers you want for a video card? Is it gigahertz?
It's for video cards. They are rated in speed, and then another thing that you have to consider is that each graphics card has become like its own computer now in a sense. So I'm not sure you guys can see this. Well, on the back there are these 4 main screws right here. So those 4 main screws translate to these 4 pegs on the back of this motherboard. Because this graphics card, all graphics cards actually have a dedicated processor in them nowadays. So you can't really just run off of what's the best, like fastest number or anything like that. You can do that, probably be fine. But what I would recommend doing is just looking at reviews, seeing how each person like reviews different graphics cards, looking at a bunch of like PC magazine or Kotaku. I don't think Kotaku does reviews, but like look on different sites, see if you can find reviews for each graphics card. Like Newegg reviews are great actually, because then people will say like, this is running fine, it runs my games at this many frames per second, I'm running on ultra settings, yada yada yada. They talk about their setup and they talk about what frame rates they're getting. And on a note about frame rates, in game, 30 frames per second is what's cinematic nowadays. So that's what the Ubisoft quote. And the whole idea is that frames per second is literally how many frames are displaying on the screen per second. You think of it like a reel-to-reel tape. I'm pretty sure you guys all know what frames per second is. So if you have the most, so like if you have 30 frames per second, it's like really going by pretty fast. If you have 60 frames per second, that's twice as many actual pictures appearing on the screen, and it seems smoother to your eye. YouTube did this actually, I think 2 years ago. They implemented 60 frames per second video, and everybody freaked out because it looked really smooth, really weird. I remember when I first saw it, I thought that there was some prank bug, but it really does look better. Your eye can see a difference. Don't let anybody really tell you differently. And then usually you can go up all the way up to 1440p, which is, or sorry, not 1440p, but like 1400 frames per second-ish. And that again depends on your monitor, because sometimes your monitor can't handle faster than 60 frames per second. So for example, my monitor that I'm running right now can't run more than 60 frames per second, so I wouldn't benefit from getting like a 980 Ti, which is the top of the line card in NVIDIA right now, because my monitor physically can't display that. My monitor is 1080p, that's 60 frames per second, so I'm not going to be running like 4K resolution at 120 frames per second. Like I'm just not going to benefit from that. So that's the graphics card side. And there's always AMD or NVIDIA. Each one has something to think about. And so you just like look at reviews, see what everybody wants. If you want to go with red team or green team, this is technically what people like to call them, red team, by the way. And another thing you can look at is game bundles. Like what games are bundled with your graphics card. It's a totally legitimate thing to think about, because if you're thinking about, okay, you want to spend an extra $50 and get a slightly better graphics card, but and it also comes with, you know, I want to say Assassin's Creed, but let's not go there. Say it comes with like a brand new title that's coming out right now, like Tom Clancy's The Division. Kind of looks cool. I'd like to play it. Why not? If it comes free with the next step up, you can sort of justify, okay, that's $50 more. My price performance is going up since I'm getting a better card. I'm spending more, but I'm getting an overall better card, and I'm getting this free game with it. I should go for it. Or on the other side, you know, if there's a card that performs worse, but it comes with a free game, but it's the same price, but it's like the same price as a card that doesn't come with a free game, you kind of have to think about that and weigh for yourself. Because usually there's a sweet spot. The sweet spot right now, as far as computer building, is probably in the $1.5, like $1,500 range. It's probably the sweet spot as far as price and performance goes. Any higher than that, you're getting more into like diminishing returns on how much you're spending. So like you'll be spending $100 more, but getting like, you know, 4 frames per second or something like that. So there's that sort of to think about as well. A lot of reviews. I recommend reading a lot of reviews. Also, Linus Tech Tips is a great channel to watch if you want to learn more about building a computer. I think you probably watch his videos. I actually have the case. Remember the first video that he does in the Cooler Master Scout, the white one.
I do not.
Oh.
Can you say?
I've got that.
Can you say that channel name again, Scott?
Linus Tech Tips. Yeah. So he also has a cool channel called Channel Super Fun, where he does really goofy stuff with semi-tech related stuff. jousted with pool noodles on those hoverboards. I don't think he also has Linus Cat Tips, which is an adorable channel you should also watch. Anyway, back to computers. He's actually where I learned how to build computers, so I highly recommend it. He's a really great guy. It's, you know, on most cases with most components and most graphics cards, he even has overclocking tutorials and stuff like that. It's a great channel overall. Does anyone else have any questions about about picking out your components? And I will say that is definitely the most complex part of building a computer.
So what else are you getting out of your graphics card besides frames per second?
Frames per second, you're getting frames per second. You're also getting, I mean, that's the main thing. It's also computing physics. So before in like, I'm not going to date how long ago, but a while ago, it used to be that you would need a like physics accelerating card that you would plug into your motherboard, and it would run like, I think there was one made by BFG before they went out of business, and it would do dedicated physics. That's all it would do. It wouldn't do graphics. It wouldn't compute things. It would literally just calculate how objects moved in the game, and it would be like increased performance, something like that. And it was a good idea. It actually started to take off. Dell started to put it in their own laptops, but then NVIDIA bought BFG, I'm pretty sure, and then they started just integrating it into their own cards, which is NVIDIA PhysX, which now AMD's adopted their own version. So now all that physics work is done by the graphics card itself. So that's where most of that comes from. And the graphics card just does most of the computational power of games, you know, just trying to render things. Whenever it's showing up, that usually translates into frame rate drops. It'll be drawing something on the screen while it's computing the next frame, and then it's trying to erase the previous frame. So it's all very technical and intense, which is why graphics cards run hot. There's an inside joke about the graphics card that I have, which is AMD's top of the line card of 2 or 3 years ago. It's the R9 290, and it was known for being a very, very hot card. It was a great performing card, it was very hot. It was, and then if you had the graphics cooler design, it's also very loud. So again, there's a lot of trade-offs you have to do in California. Am I okay with more heat and it being louder and it be drawing more power, but with more frames per second, better computational power, that sort of thing. On that note, I guess we'll jump into power supplies. This is the power supply that we have in this computer right now, or it was, we'll sort it out. But this is the Corsair CX430M. Usually there's a number in there that's 430 watts. That's how much power it can supply. And in this computer, 430 watts is fine. I think I calculated it out. There's a Cooler Master is another manufacturer of a lot of computer parts, and they actually have a really, really good computer wattage calculator on their website. And basically, you enter your processor, you enter your graphics card, your motherboard, all of those things, and it spits out a number. I think when it spit out this build, it was like, this build's going to take 375 watts or something. So remember how I was talking about that other card runs hot? Well, it runs hot because it's taking so much power and it's doing so much at the same time. So if you're like in your own apartment or something like that, and you have to worry about your power bill, that might be something you want to account in as well. If you want a very high performance card, if you want a card that's like pretty well managed power. And there also is a standard of power supplies, which I don't know if it's written on here. It's not. But most power supplies have a 80 plus gold efficiency, 80 plus bronze efficiency, 80 plus platinum efficiency. And what that means is that like 80% of it, 80% of all power is being used and not wasted in heat or anything like that. So obviously, bronze is okay, silver is better, gold is better than that, platinum is amazing, all that other stuff. And most power supply manufacturers, as well as most any manufacturers, another safe thing when you're picking out components is pick brands that you've heard of before, or at least read and use a lot. So it's like you see an XFX power supply or graphics card, that's probably fine. If you see a SUSE graphics card, that's going to be fine. The Corsair power supply, that's probably going to be great. If you have like a power color graphics card, probably not on the same level as an XFX or EVGA graphics card, because there's a lot of different manufacturers. All those manufacturers just listed do the same thing, where they'll take the same graphics card given from the manufacturer, NVIDIA or AMD, and they'll put their own cooler on it to try to get a little bit more performance out of it. So that's what that sort of thing is. So just make sure that you buy brands